Good day, all of you. Welcome to electrical testing for computer part. Today in this session, I will be explaining experiment 3. So before I go for experiment 3, let me show you, let me share my screen with you so that now I hope all of you see my screen on your laptop or on your computer. So to begin with, today in this experiment, we will be starting experiment 3. As usual, how you have done for the previous experiments. Okay, you have to write today's date and your submission date, your deadline, name of the student, university ID, section, okay, and your lab number as per in your academia. And this is experiment 3, so mention the title and objective of this experiments, and this table you have to fill as how you have filled for experiment 1 and 2, but you have to do this at end. Okay, and another important thing is, while submitting this report through Blackboard, it is very, very important. Please remember, it is very, 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 very important that on every paper you mention your Rakam Jamai, you mention your rule number. It's very, 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 very important. If you don't mention on any paper your ID number, then it will be treated as a copy. Okay, so please make sure and note down this point, that on every paper you are submitting, for example, you are submitting total 5 papers. Okay, then on every page you need to write your rule number. Okay, university ID, it's very important. Then after that you can convert that page into the PDF and send in an assignment. Okay, so let us start that. We have in the first experiment, okay, we have this push button, and we have a keyboard and ASCII displays. So I'll show you how to give connections, okay, in the simulator. So what you have to do is, just let me open this, click on start, go to multimedia logic, click close. Let us make this window a little longer and zoom in so that, and here I didn't find my toolbox, so you know that we will go and click on toggle palette. Okay, and we get the toolbox. Once we get the toolbox, let us give connection. First we need a push button. How do you get a push button? Push button is a switch. Click on switch. Okay, bring it here. Now click on the selector so that I can right click on this switch, go to properties. In the properties you get two types, toggle and momentary. Click on momentary and then click on OK. Now this has become a push button. Okay, and when once you get this push button, the other component which we need is the ASCII keyboard. Okay, this is the keyboard, right? Now you have this keyboard. See that this keyboard has 0 to 7 connections, and one is enable button, and then we need third component, which is ASCII output. Okay, ASCII display. Now, how do you give connections? Please have a look onto your lab manual and just see how we are giving connection. Let us see carefully. I'll click on wire, I'll select the wire, and I will start giving the connection. Make sure that from push button we give it to R for both the ASCII displays. Okay, ASCII stands for American Standard Code for Information Interchange. Okay, I'll show you how to write the report also. So the what I'm doing is, I'm not I'm giving R from push button. I'm giving to R only once, and then from the keyboard enable has to be given to both of this ASCII display, CT and CT. Okay, why I have given to only one ASCII display? Because when I click on this push button, it will reset the contents. Okay, so now let us give from this 0, give 0 to both of them, to the both of ASCII displays. Okay, similarly let's go click on one and give one to the both of them, the connections as shown here. So watch carefully that we have to give connections very carefully. Similarly, I give for 3, sorry, 0 or 2 and 2. We are starting from 0, 1, 2, right? It's 2. So we have to continue giving the connections as it is. So it will take time. Let me complete this. Okay, only 3 more remaining. So make sure that you have to click on the black and click, drag it without leaving the mouse and see like this, click, drag and leave on the spot. Okay. Yeah, so we have last but one, but to make sure that you are not mixing up, make sure that the connection is one to one. So this is how we give. Now the important thing you have to observe here is after giving these connections, you see this is not running. The cycles are 0 here. Okay. Now I will click on run simulation. Already you know that how to run the simulation. Okay. So click on this run simulation, start running. See, by default, the keyboard is disabled. Okay, it is not working. You just type your keyboard. See, it's not working. Okay, but when you click on this, now my keyboard will start work. When I type something, okay, it will be displayed. You see, welcome to testing for lab something. Whatever I'm pressing, you see here. You see, I'm going to next. Just I'm typing some junk characters. I'm clicking on reset button, push. You see, because I connected R to only this push button, only one screen is getting cleared, other is not. Why? Because I have not connected the push button to R. Okay. Now let's see. I'm just typing this 1, 2, 3, 4, 5. See, one total. You just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you just see how many rows and how many columns you are having. We have to just count it and we have to write here. Okay, so I just reset it, stop it. Okay, in one screen you have to mention how many in rows, how many characters I can store and how many lines we have. So you see in part A, okay, I write ASCII display. What is ASCII display? American Standard Code for Information Interchange. Push button. You have to write all these things, that we right click on switch, go to properties, type is equal to momentary, click OK. Then you have to write comment. It's very important that when we run this circuit, by default keyboard is disabled. To enable it, click on it, and ASCII display has 8 rows and 16 columns, as you have seen. But you see here input device, output device, and control device. I have not mentioned anything. It doesn't mean you have to write the same thing. You have to write that what input devices we have used here. Okay, ASCII display is an output device we have used here. Push button is an input device which we have used here, and what are the control devices we have used here. Okay, wires we have used here. Okay, so all these you have to complete this part. Okay, so similarly, see, for ASCII display, I have explained you it's an American Standard Code for Information Interchange. And for push button, how you get the push button? Okay, right click on switch, go to properties, type momentary. All this you have to write in your lab record. Please don't write this as separately how I have written here in the notepad. You have to write this at the same place in the experiment there itself. If you have space, or if you don't have space, turn your page back and write. Okay, but don't write all experiments separately and all these comments separately. No, part A should be written with part A, part B should be written with part B, part C should be written with part C. Okay, and make sure that comments you should not miss. Okay, comments you should not miss. Okay, the other is you are using keyboard also. So let me write keyboard. You have to write about this keyboard. How do you write read from the textbook which I have uploaded in the blackboard, which I have provided to you. Okay, so read from that, understand it, and write in your own words. Okay, see, I'm just showing here. This is the our textbook which I have uploaded in the blackboard. Okay, a textbook for electrical testing for computer part. Okay, by Salman Alfaz Muhammad. Just search here keyboard. When you click on, you'll get the keyboard device. Now read, understand this. Don't copy and paste as it is. Read and understand. When you read these 4 5 lines, understand and write them in 2 3 lines. Okay, in your own words. What is this keyboard doing? What is this component doing? Okay, this is very important that you have to do this. I'm not writing here because this is what you are supposed to do. Okay, so don't copy, paste, read once, understand it, and then write in your own words. Okay, yeah. Now you also have to mention, let me just see all this. Next is comment. Okay, it's very important. You have to write this, that when we run this circuit by default keyboard is disabled, right? You remember when we run it was having some disable symbol. When you click on it, it enables, right? You see, when I run this, you see it is disabled. Okay, when I click on it, it's enabled. When it gets enabled, my keyboard starts working. Okay, yeah, and we counted that this ASCII display has 8 rows and 16 columns. In one line, you can have 16 characters, and like this, you have 8 lines. It means. So, what input devices we have seen? Okay, we have seen push button, an output device, ASCII display, control device, wires, and the important thing is from this experiment, because we are learning many more input and output control devices, so you have to mention this new component in every part. Okay, see wire and all these things you have already know this, but this is not new component for you. In experiment 3, what you have learned the new component, you have done about push button, keyboard, and ASCII display. So these are the 3 new components which you have learned. Okay, so which you have learned this. Now let's go for part B. Okay, so I'll just stop it and I'll go for new project. Before I go for new project, I will show you. See, this is our next experiment, 7 segment LED, and we have this all switches. Let us see, implement them, okay, and understand how we'll do it. So let's get one LED, 7 segment LED. You see, observe this 7 segment LED is having only 4 inputs, but in the diagram it is giving us 8 or 7 inputs. So right click, go to properties, okay, select type is equal to 8 inputs and click on OK. So when you click on OK, you got total 8. That's great. Now let's have all switches now. Okay. So how many switches? We have switch 1, switch 2, 3, this 4, this 5, 6, 7, 8, 9. Great. So the important thing is you have to give names. Labeling is very important, all of you. You in experiment you'll give labeling, and in your paper which you are submitting in assignment, the lab report, you have to write this. Okay, this button is switch 0, this is switch 1. Okay, you have to give connections like this as how I am showing you here. Then switch 0, switch 1, this is switch 2, this is switch 3. Next, oh, it's not connecting. Let me do it again. Should be very careful that you drag the mouse without leaving it and leave at the black point only, otherwise it will not give you connection. So bear with me, let me complete this connection. So this is extra, select delete. Now let us give names now. Now you see here I give this as switch 0, switch 1, switch 2, so on up to 7 switches. Just see how am I doing. All these you have to write in your lab report also, okay? You have to give the name to each and level. Most of the students will do mistake, they'll write from S0 from above. No, please write it from bottom, okay? Yeah, after this, now let me run it. Now you have to prepare one table also. I'll show you how to do that. So let me first. So here, all of you, you have to draw the table here, okay, and record this. Right here, S0, S1, S2, S3, S4, S5, all this. Let me see. I'm running now. So when I run this, look here. Now, for example, I want this number as A here, for example. So you see which one is, you see it has become A dot. Okay. So for A dot, you just observe that except S2, all are on. Okay. So what you have to do is, here you have to prepare this. Let me organize this. Yeah, let's use this pencil. So here I write mm, or- so I'll just write the table like this. So let me show you quickly. So you have S0, S1, S2, S3, S4, S5, S6, S7. Let's create the table like this. I'll show you an example of A dot only, as I've shown you. The remaining what I'm showing you, you have to please fill it, okay? So I'm doing showing you A dot. Sorry. Okay, so here you have A dot. You see in A dot only this is 0, all are ones. Like this you have to record. Similarly, I will show you some more. You have to write here. Okay. Like this. I'll show you the another thing. Okay. Some other. Okay, you see, these are all 7 segment LEDs. Okay, second time I'm taking 5. So you see, just see, I'm just turning on, in which I get 5. So next note down that here I have to mark it for 5. Okay, you have to fill it. Okay, you have to fill it here, the report. Similarly, you see this is 9. For 9 it's like this. Okay, and for 5 we have like this, and like this to F. Okay, all hexadecimal digits you can have here. Okay, so I stop here, and you see, how do you write this? Okay, this you have to write at the same place in the experiment. Okay, not separately. Because in the notepad I'm showing you separately. Here we are using 7-segment LED. How you get it? Right click on it, go to properties. Okay, because by default it has 4 inputs. You have to go to type and select 8 inputs, then click OK. And you are using 7 switches, and you are using text also. And table, as I have shown you. Okay, draw the table like that. Okay, just now I have given the table. Okay, follow that. Draw the table here. Okay, in this space, no problem. So here also you have to mention input, output, and control devices. Okay, write the name, and also mention that what is the new component you have learned. Okay, already you have seen the switches. Okay, switches, already we know that. This is not the new component. In this part you have learned 7-segment LED, so write that. So this is the text. Okay, yeah. So input, output, control, and the new components, mention it here. So let me type. Just now I have given you the following labeling. Okay, labeling is very important. What labeling? That for every switch has given name. You see S0, S1, S2, S3, S4, S5. This is the labeling. It's very important. And mention that this is 7-segment LED. Okay, all this labeling is important. As of now, you know that in 1 and 2 experiment, how you have done labeling, do the same way. Okay, labeling is very important. Okay, next new component you have learned about 7-segment LED. Okay, so write about this 7-segment LED from the textbook as I have shown you. Okay, now let's go to part C. Okay, this is your part C. Right, let's do that. How we are using clock and buzzer. Okay, so let's see. In we are using timer and buzzer. I'll show you how to give connections to this now. Already you know how to get the push button. Okay, so this is the push button. After you get this push button, get the clock. Okay, then get the buzzer. Now you see this is given 1 by 10th of a second, means in minute. In 1 minute you have 60 seconds. 1 by 10 means see, let me just show you the connections first. Let's give connections from push button to clock, and then from clock to the buzzer. Now watch carefully. Go to properties, and you see, select 1 by 10th of a second. You hear the delay is 1000, which is given already. Okay, so 1 second, this is, you see here it's fire once a second, and here it's beep 1 by 10 of a second. 1 by 10 of a second means this is 1 second only. So in 1 second you have 1000 milliseconds. Okay, and 1 by 10 second means you have 100 milliseconds. So buzzer, go to properties and put here click properties. Give here duration is 20. No, not 20. This is 100 milliseconds. Okay. Then click on OK. Now you see, observe closely. When I run this, okay, I'm clicking, going on, pushing the push button. You see, you will get one sound. You see carefully. Carefully observe the buzzer. You see, just now you got. Okay, you got the sound like this. You have to observe it carefully. Okay, give this connection and check again. See, I'll show you again. No, well, yeah, just see here. Part C timer you are using. Right click, go to properties. Then delay is equal to 1 second. 1 second is 1000 milliseconds. Click buzzer 1/10th of a second. So how do you set? Select, click properties. Duration is 100 milliseconds. Click OK. And what input and output control devices we are using? Please mention. Okay. This is very important that you have to mention what input devices we are using. Timer is an input device, buzzer is an output device, or the control device you are using, wires. Then the new component which we have learned in part C is, before we didn't see timer and buzzer. So these are the new components. Okay. Push already we have seen. That's why we don't write it here. New component here is timer and buzzer. So let me show you part D now. This part D, this select and this text, I'll show you how to give the connections for this also. Okay. So let's go for the project. Zoom out. Sorry, zoom in and let's give the connection. See, this is the select. Click on this select. Then click on text. You see, by default, text is simple text we have used. But how to connect wires for this? Click on selector, right click on the selector, right click, go to properties or double click anything. Then click here, type is equal to multiple. Then you get here text box. Now it's very simple. Create the, now give the connections. Select the wire and give from 1 to 1, 0 to 0, 1 to 1, 2 to 2, 3 to 3 to 3. Now after giving this, let me give connections first. Now if I run, you see I will not get any output. Why? This is not the output. You see, I'm selecting is getting. Why? Because actually we have to create one file and we have to link that file with this text box so that I can see the contents of that file. So for that, what I will do is click on start, type notepad here, or you click on notepad. When I click on the notepad, okay, see, I'm just typing some numbers or names. Let me take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But I'm giving some extra 16, 17, 18, 9, 18. Okay, these lines I have given. Save it. I'll save it with on the desktop with names called numbers. Okay, numbers.txt. See, on desktop I saved it. Okay. Now after I save, what I have to do is I have to right click on this component and go to properties and see, right click on text, go to properties. Now here you have, see, file name. Click on this browse and go to the desktop and select our file what we have created, number.txt, and click open. When I click open and click OK, now you see here it is linked now. Now let us see. I just run it. You see 1, 2, 3, 4, 5, 6, total 18 lines I have given. Remember, now you see after 15, what happens now? 16, yeah. After 16, it will not go to 17. It will start from 1. It means the select component has the ability to select only 16 lines from a file. Even though if the file is having 20, 30, 100 lines, it selects only 16 lines. You see, after 16, it is okay. But sometimes you see, always starting from line number 1. Okay, but I want to set something. No, I want to start it from not 1. So I want to start it from uh, some other number, okay, which is 5. So I just set it, you see, starting from 5. Okay, so you can set the starting point also like this. You see, when I run, it starts from 5 because I have selected 5. If you want some other number 2 or 10, whatever, go to properties, select that location, file in hexadecimal, and it will give you. Now it's very important to write the report part. See, part D now. This is, so we are using the select device. The select device can display only 16 lines. Just now we have seen that, okay? And next we have used text, but this text is different. Okay, right click properties and select style is equal to multiple. Now all these steps, right steps for the connections and output, like you have to create notepad, save it, desktop, all those steps what I have shown you, you have to write in your own English here, please. And after that, as usual, mention what input, output, and control devices you are using in part D. Okay, followed by the new components. What your new components we have used in part D? We have used select. We use text, but text with multiple options. This is first time we are using. Okay, that's why I have written here. Okay, select and text with multiple options. So all these things you have to write in your lab manual. Sorry, your lab report while you're submitting this to me on the blackboard. Okay. Now, there comes very important part, which is part E. Let's see what is this part E. See, this is part E. Okay. Now this is multiplexer, demultiplexer, and we have these connections. According to this, let us give the connections now. Let me give the connections of part E. So this requires one table also. Let me show you 1 minute. Connections. Yeah, let's go for the new project. Now you see, according to the report, I'm just giving connections. You just have a look on both. I'm giving connections. It's very simple. Now here we are using multiplexer. See, I'm selecting mux. This is very tricky here. By default, the mux is 8 to 1 multiplexer. Okay, I want one mux, I want one demux, but both are multiplexer. How to change? Go to right click properties. See, what do you want? I want 2 to 1 mux. Click OK. And here I want 1 to 2 demux. So go properties and 1 to 2 demux, demultiplexer. So you see accordingly we get the, from one multiplexer component we can set different properties and can have multiplexer according to our requirement. Okay, so let's give connections to this as per given in the lab record. I have this OR gate, then another OR gate as shown in the figure, and we have LED one, this LED two, third, 3 LEDs, and let's give 2 more LEDs here. Okay, one is Y, another will show you Y complement. Okay, that's now there is one more AND gate, actually one AND and one OR gate, not 2 OR gate. So I select com wire. Let us give connections now. You see carefully how I'm going to give connections. Okay, it's very important, and this labeling is also very important. Which button is what? Okay, so let me give this connection. Okay, this is S. From S I give to S. Okay, and this from S I give to S because both are S. So this S switch connects to this both S. Then next I have, you see, I'm just giving labeling to all. This is S0 and this is, sorry, this is S1 and this S0 switch. So S0 will connect to 0, 1 will go connect to 1. You see, 1 is connecting to 1, S1 is connected to 1, S0 I am connecting it to 0. Now let's give table, this is your output Y and this is Y bar, another one is Y bar. See, Y is, I'm connecting it to Y, and the complement is of Y is this another LED. Okay, so if Y is 1, Y bar will be 0. If Y is 0, Y bar will become 1. So it's just a complement of Y. But you see, we are giving this Y to an input to enable. Okay, and to know that this Y bar is 0 or 1, we have an LED. Let's connect to that LED also. Okay, now let us give this. This is what? This is E bar of 1 to 2 Dmux. This E bar of 1 to 2 Dmux. Correct? Because I am connecting from here to here, right? So 1 to 2 Dmux. So, but this E of multiplexer, from where you have just see the connections. Yeah, according to the connection, let me give this connection from here, this switch. Yeah, let's give connection like this. Yeah. See carefully. After I give this connection, this output is connected to E. Okay, and this E is 1 or 0. I can know from this LED. Okay, so let us label this LED as E bar of 2 to 1 max. Okay, E bar of 2 to 1 max. Half of the connections we finished, but we have to give some connections to Dmax also. So let's give 1 to this one and 0 to this 0. Finish. Okay. Now let us see the connections. No, sorry, let's see the output now. For this output, see how to capture the output. I'll show you. We will be using one table. I think I'll show you the, I'll show you the table. Okay. Now you see here, according to the connections, we have 2 to 1 mux, okay, and dmux. These two things we are having. So how to give? Yeah, first we'll write a table for 2 to 1 mux. Okay, so in 2 to 1 mux, you see we have e bar and s and s0 and s1. Okay, so we have an e bar and we have s0 and s1. Okay, then we have an output also here. So you should be very careful while drawing this. Now, why? Now look here, S can take 0 or it can take 1. Okay, when S is 0, we will check for this SS is 0, 0, 0, 1, 1, 0, 1, 1. Okay, just draw the table like this. So what happens if S is 1? Okay, again 0, 0, 0, 1, 1, 0, 1, 1. Okay, here this is in case where E bar is 0. Okay, so like this you have to fill table like this. What happens if E bar is 1 and this is 0? You have 0, 0, 0, 1, 1, 0, 1, 1, and here if it is 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so now from here you have to just capture the output now in these cases. Okay, so now look here, I'm showing you now. S is 0. Let me run the experiment. Look carefully. I have S, S0, S1, okay, E bar, okay, Y. All this I am having in the table, right? All these are there. A bar, S, S0. I have this E bar of 2 to 1 mux. This E bar. Okay, this is S, this is S0 and S1. Okay, so let me run this. Okay, see, I'm running. See, when I run, it's all giving me output. First, I want E bar to be 0. Okay, so yeah, this is 0. I set E bar is equal to 0. and then this E bar is 0. Okay, and now S is 0. Okay, S is 0. Yeah, and S0 S1 is also 0 0. So I got output Y is equal to 0. Okay, so I write here Y is also 0. Next, what I will do is 0 0. Now I have, this is S1 is 1 and S0 is 0. 0 0 0 1. Yeah, you see S0 I make it 1 and I get answer 1. S0 I make it 1, I get answer 1. Okay, then I make both of them 1, I get answer 1. Okay, but if I make S1 is 1, now you just look carefully and fill the table like this accordingly. Okay, now I make S0001, 1011, all the combinations I'm showing you. You just see. I'm not writing the table here. You have to write the table like this now. Give the connections and fill the table like this, how I have shown you. I'm just showing you the outputs. You see, I made S is also 1. So if you give connections in your computer or laptop, then you can check it easily. I'm showing you all outputs, but I'm not reading and I'm not writing it because I want you to do and fill the table. Okay, but I'm showing you all steps here. You see, I make E bar as 1. Okay, S is 0, S is 1. Just record these outputs. You see, in this case, when E bar is 1, none of them is working. So there is no output in this case when E bar is 1. Okay, if E bar is 0, it is working. So you have to fill all these cases. You have to fill all these cases. Okay. So give connections like this and practice at home and fill the table. Okay. Now the next part is about demultiplexer table. Okay. Now you see in demultiplexer table, you have E bar and S. That's all. And this is E bar of it. Let me show you. Then you have 1 to 2 demux. 1 to 2 demux. In this, you have E bar and you have S. This can be 0 or 1. If it is 0, what happens? If it is 1, it can be 0 or 1. Okay. So here output, you see how you have to do it. I'm just showing you. See, if S is 0 and E bar is 0 and S is 0, E bar is 0, then the 1 is red, 0 is black. Correct? This is red, is black. Then next I make S as 1 now. Okay. S is 1. You see, If it is 0, 1 is red, 0 is black. Okay. Now I make S as 1. Yeah. So 1 is black, 0 is red. 1 has become black, 0 has become red. Correct? Now this is in case of E bar is 0. Now E bar I will make it as 1 now. You see I change it 0 0 1 1. It is same. 1 is red, 0 is red. There is no change here. It's me, it's not working. 1 is also red, 0 is also red. Here also the same case. Okay. So right, 1 is also red, 0 is also red. Okay. So like this you have to capture the values from the table. Okay. So how do you write this? A party C221 mux, 122 dmux, and table. There are two tables I have shown you. Okay, this 221 mux and dmux. These two tables, mux and one for one to two dmux. We have two tables. Mention all input output devices and all the new components what you have learned. New components very important. Here you have learned about multiplexers, right? Mux and demux. So you can write in new component as multiplexer and demultiplexer. Go to the textbook, read it, and write about it. Okay. So next is as you know that we have this. This is ASCII keypad, ground, memory device, and 7 segment LED. So here is the ASCII keypad I have taken, and this is the ground. This is the ground. Okay, if you have not seen, I'll show you again. Yeah, look here. Let's go for new project. Stop it. Okay, and make it big. And yeah, see ASCII keypad and ground. Do you see ground here? Yeah, this is ground. Now we have to take this components which is shown in the diagram. So the next component, where is this? Where is this? You have to search like this for any components. You'll see the name, and then you'll stop here. So I'm searching for the component. Yeah, this is memory. Okay. So I got memory. Then we have one more ground. Ground. What is already there? Now let's see how I'm giving the connections with two keypad keys. I have two keypads and we have 7 segment LED also. Okay, let's see the connections. How we are giving the connections. It is very important. So this is the memory. Okay, and you see from 0 I give it to 0. You see, watch carefully how am I giving. Okay, 0 to 0 and 1 to 1, like this you have to give 0 0 1 1 2 2 3 3. I'm not showing you here, just give it like this. Similarly for here also, give from 0 to 0 and 3 to 0 to 0 1 to 1 2 to 2 3 to 3, like this. Okay, I'm not giving, you have to give connections here. Okay, then you see after this above are remaining empty, that we will connect with grounds. Okay, that we will connect with ground. You see how I'm connecting it. This keypad, ground, memory, and 7 segment LED we have used. Okay, You have to write the comment that the memory device is used to store information of 260 bytes, and what input, output, and control devices you are using. What is a new component you have learned? Okay, and make sure that you should mention what are the new components, input, output devices, and read the textbook and write about that. Similarly, see if from this ground all are going like this, okay? And just give connections according to this. It is finished. Last part is oscillator. This is oscillator, this is buffer, and sensing LED. I'll show you how to give these connections also. Okay. So this, how do you get the buffer? Okay, this is how you get the buffer. You see, this is oscillator. You can search from here. This is the oscillator, and then this is not gate. Okay, right click on this, go to properties. Okay, and invert output and click OK. This will become a buffer. Buffers are generally used to introduce delay in the circuits. Okay, so like this, you have to go to this part and write that in this part G we have used oscillator buffer. How do you get buffer? Right click on invert properties, invert output buffer. We are using sense segment LED. Don't forget to mention comment that a buffer is used to introduce delay in the circuits. And what are the input and output devices, control devices you are using, and what is the new component you have learned here. I think oscillator is the new component here, correct? Oscillator and buffer also is the new component for you. Okay, so make sure that you complete all these things. Okay, so don't write this how I have written in the notepad. You have to write every, like this is part C, all these details you have to write here. It's all, it should be filled. Okay, don't write separately. You have to write part A under part A, part B under part B, part C under part C. Okay, wherever which part you are discussing, all these notes you have to write in that under that part only. Don't write separately all part A, B, C, writing separately and experiment separately. No, experiment itself you have to combine these parts. Okay, so I think okay, this is enough now. We have finished this experiment 3. Okay, hope all of you have understood. If you have any questions, you are welcome to ask these questions through your course messages. Okay, and the deadline of this experiment is you know that you are getting one next Thursday, so finish it and send us before the deadline as soon as possible. Okay, so see you next week, inshallah. Goodbye.